Hello! Alrighty folks, here we go. Short video this time. I want to take the step of inverse numbers in modular math one step further. We want to notice something about these. So I've got for you here mod 7 and mod 6. And I've written up the numbers for each one of them so we could find our inverses really quick. So we'll review that really quickly, and then I want us to notice something, and that's all we're going to do right now. So when we do this, remember we need the list of ones. So we know that 1 is always its own 1, and we keep adding the mod to it. So I'm going to take 1 plus 7 and get 8, and 8 plus 7 is 15, and 15 plus 7 is 22, another 7 is 29, gosh, another 7 is going to be what, 36, keep going, mod 7, uh-oh, do you see my mistake? I do. How many numbers are in mod 7? 0, 1, 2, 3, 4, 5, and 6. I put the extra number, didn't I? So let's get rid of that. So why did I stop at 36 here? Because we remember the last number in the mod times itself is where we stop here, because the last number is its own inverse. 0's inverse is what? Right, there isn't one. So we're just going to put a line this time. 1's inverse, 1 is already 1, so 1's its own inverse. And the rest here we have to figure out from our list of 1's. Because remember, the idea here with finding an inverse is it's what number do you multiply with to get back to the identity, which is 1 in the multiplicative identity in this case. So 2 times what of these numbers gives us one of these? Yeah, 2 times 4 is 8. So 2's inverse is 4. 4's inverse would be 2. 4 times 2 is 8, right? And gosh, what do we have? A 3 and a 5 left. If we did that, there's your 15. So 3's inverse is 5. 5's inverse is 3. So we could do some modular math algebra with this if we wanted to. You did some practice that. We'll do some more practice in another day. But what I want us to notice is that we have inverses for everything except what number? The 0, right. Let's go on to mod 6. And let's do the same thing. So our list of 1's, again, starts with 1. And then 1 plus 6 is 7 this time. Notice how the list of 1's is different in a different mod. So 6 and 7 is 13. How far are we going to go? Right, to 25. So 13 and 6 is 19. 19 and 6 is, there it is, 25. We land right on it like we should. So now 0's inverse is what? Yep, no inverse. 1's inverse is itself, and the last one is also itself, because 5 times 5 is 25. So now let's try to figure out what other numbers we can multiply to get these. There's a problem, huh? It's not happening, is it? Huh. And that's the case. That's the truth. It's not happening. Not all mods have inverses for every number. And in this case, we just found a mod that's got 3 of them that aren't there. All of them don't have one for 0, but some of them have a inverse for every number, and some of them have an inverse for some of the numbers. So when you do the homework tonight, part of what you're going to do is you're going to find some of these that don't have inverses for every number, and then they're going to ask you, why? What's the difference between the two? So I'm not going to tell you the answer to that one. You're going to have to think about that for a few. But no, the question is, what's the difference? Why does mod 7 have inverses for every number but 0, but mod 6 is missing more than just the 0? That's the thought. That's the problem. So folks, before I say goodbye to you on this quick vid, I got your popsicle joke. What kind of band plays snappy music? Snappy music is from what kind of a band? Yes, a rubber band. See you later, folks. Enjoy.